Mr. Richmond, this is your Integrated Math 2, Unit 8.3, 8.4 lesson summary. We're going to continue our study here of the trigonometric ratios. We did tangent last video, and we're going to do the other two today, sine and cosine. So let's start with sine. The sine ratio, abbreviated SIN, I like to use, remember using this, SOH or so. So we have so, and then for cosine we'll have ka. You put it all together, we have so ka to when you add the tangent. I'll write that again in a second. But sine is opposite over hypotenuse when dealing with the reference angle. The side opposite the reference angle over the hypotenuse. Cosecant will be the inverse of that, it'll be that flipped. So the cosecant is basically the opposite of sine. We'll flip that and go hypotenuse over opposite. Just like we had inverse tangent, we also have inverse sine. Sine -1, or the sine inverse, sine to the -1 power, is the measure of an acute angle whose sine is x. We use that in reverse to find angle measures. Cosine, ka, adjacent over hypotenuse, adjacent over hypotenuse. Its reverse, secant, is hypotenuse over adjacent. And the inverse cosine, just like the other ones, cosine to the -1 power, or the inverse of cosine, is the measure of an acute angle whose cosine is x. And again, we'll use these inverses to find angle measures. So let's kind of bring this all together. That's a lot of info. If I had a triangle, let's call it ABC, and it is a right triangle, and let's use A as my reference angle. Okay, the sine of it would be opposite over hypotenuse. Opposite over hypotenuse. Okay? If I said let's find the cosine of A, that's supposed to be adjacent side, non-hypotenuse, over hypotenuse. Okay, and so it's just a different trig ratio really. In all these trig problems, what you'll typically have is an angle measure in one side, and so whatever missing side you're looking for, you can make a variable or try to find the variable they want, and you just have to choose the correct ratio that goes with it. And one of the ways that they'll tend to test you on this stuff is by giving you basically everything, but asking you to find sines or cosines or cosecants or secants or tangents or cotangents of individual angles to make sure that you really do know each of those ratios and that you're not going to get them mixed up. So study the heck out of this. Make flashcards, make problems, whatever you do to make sure you never forget these ratios. You always can spot them. And we'll practice that there first in the first example. Then we'll take a look at the sine inverse, cosine inverse, and how to actually find missing sides and find missing angle measures for right triangles using these ratios. Okay? Other thing to be aware of, sine's kind of opposite is cosecant. So sine and cosecant. Whereas sine basically just gets a co in front of it to be cosine. So its reverse doesn't have the co and is secant. Very common mistake to put sine with secant and cosine with cosecant. Make sure you don't make that mistake. So if one doesn't have a co, then the other does. If one has a co, then the other doesn't. Okay? That's kind of how I remember it. All right, let's jump right into it. Now, we talked about rationalizing the denominators and roots, and now you're going to see why. It's going to all come together here with this example. So here they gave me a lot of information. They gave me all three side lengths for the triangle. They said it's a right triangle. They even gave me that that's 60. I'm going to go ahead and put in the only thing they didn't give me, that this angle is 30, and I know that by triangle sum. 60 plus 30 is 90, plus this 90 is 180, because that's what triangles add up to. And all I really have to do here, it wants me to write the trigonometric ratio, but find the exact value. Okay, that says value, but it's supposed to be the exact value. So, although yes, I could just go, okay, what's the sine of 60? Get my calculator out. My calculator loves to do that for me. Sine 60, thank you calculator. 0.866. That's not what they want. That's a rounded answer. The answer goes on forever there as a decimal. So when they want it to be exact, find the exact value of it. I can't round, so that means I have to keep my answer as a root, which means I have to use the ratio. So let's give it a shot. Sine of 60. So I'm going to use 60 as my reference angle. Sine, okay, opposite over hypotenuse. And actually, why don't we write that down so we don't forget? If they want me to do sine, it's so, ka, toa. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So, ka, toa. Sine of 60, so it's going to be opposite over hypotenuse, reference angle, opposite, 5 root 3 over hypotenuse, 10. Now, if it can simplify, you need to. Numbers in front of roots can multiply together. Numbers in front of roots can divide together. You just can't divide a root with a regular number, and you can't multiply a root with a regular number and actually change anything. 5 over 10 is equivalent to 1 over 2. So this is the same as 1 root 3 over 2. And since 1 times root 3 is just root 3, that simplifies to root 3 over 2 as a ratio. And if you want to check at home and make sure that that makes sense, do root 3 divided by 2 on your calculator and see what you get. You should get the same answer as you would get if you did the sine of 60. The difference is that would become a rounded answer, just like sine of 60 is, whereas this is exact. Okay? Cosecant, CSC, cosecant, that's our abbreviation for cosecant. Remember, if sine and cosine has to have one or the other, so sine and cosine are the ones that go together, they're opposites. So cosecant is the reverse, it's hypotenuse over opposite. So I'm going to do the same thing, reference angle 60, but instead of going opposite over hypotenuse, I'm going to go hypotenuse 10 over opposite 5 root 3. And here's where you'll have that issue. You're not allowed to keep root answers like that. So I need to multiply the top and bottom by root 3. And I get 10 root 3 over 5 times root 9. Now at this point, if you wanted to, you could go 5 times 3 is 15, but I already noticed something that can divide. I see 10 and 5 can divide, so I'm going to do that first. 10 divided by 5 is 2, so that's 2 root 3 over root 9. 10 divided by 5 is 2. And now you can just work out that root 9. Root 9 is 3. So 2 root 3 over 3 when working with my radicals. Let's try the next one. Cosine of 60. Again, just still using 60 as my reference angle. Cosine, ka, adjacent over hypotenuse. So 5 over 10, which simplifies nice and easy to just 1/2. Okay, secant is our reverse of cosine. So secant of 60 should be reversed to that. Hypotenuse over adjacent, which is 10 over 5, which is 2. Okay? So they really just reverse there. Okay, moving on. Tan of 30. Tan of 30. First time they've changed the reference angle on me. Tan of 30. Tan of 30 would be opposite, it's TOA, opposite over adjacent. Tan of 30, opposite over adjacent. So tan of 30 would be 5 over 5 root 3. 5 over 5 root 3. Okay, and there again, I can divide. I see 2 5s. 5 over 5 simplifies to 1 on top, so that's 1 over root 3. Multiply top and bottom by root 3, and you get root 3 over root 9, and root 9 is equivalent to 3, so you end up with root 3 over root 3. Pretty straightforward. Okay. Cotangent. That's our opposite for tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. And we're doing 30 again, so adjacent, 5 root 3 over opposite, 5. 5 root 3 over 5. 5 root 3 over 5. 5's cross out. I just end up with root 3. I'm going to do the cotangent. So, as you can see there, it's really just a matter of memorizing the ratios, practicing, remembering your SOHCAHTOA, and working it through. Okay? Rationalize the roots will be important. Depending on the teacher, how much they want to stress on this, though, it's a bit of algebra review, so make sure you're ready to rationalize the roots. All right, let's move into more direct trigonometric work here. So I have right triangles here in example 2, right triangle RST and right triangle, let's call that WXV. And I want to solve for the missing side length Y. Now we learned to do this with tangent, but now you'll see that tangent won't work because the angle that we have, the 61, I'll call T my reference angle, tangent would be opposite over adjacent. I don't know adjacent. So the key here now is that you start to recognize when to use each ratio. They gave me 61, so I want to use opposite over hypotenuse, because that's the sides I have in regards to my reference. Opposite over hypotenuse. Which one uses opposite over hypotenuse? Sine. So I'm going to do the sine of that angle measure, 61. Okay, sine of 61 should equal the ratio of those sides divided, which would be y, the opposite, over the hypotenuse, 18. And now I can solve. Multiply both sides by 18 to isolate the y. You do that, you get 18 times the sine of 61 degrees equals y, and now I can just work that out using my calculator. So 18 times the sine of 61, make sure degrees is on, go to mode, make sure degrees is on, and do 18 times the sine of 61, and you get 15.74. 15.74. Let's check back up. That's a side length, so I'm going to leave it 15.74. If it asks you to find ST as well, again, now that I have two sides, you can always go back to Pythagorean theorem to get the third. Okay, let's take a look at the next one. This one says solve for x this time. The angle measure that they give me to work with is angle x, so that'll be my reference angle. It's the one I have a measure for. That's a cube. And what sides do I have? I have the adjacent side and I have the hypotenuse side. Adjacent side, hypotenuse side. So that'd be adjacent hypotenuse, that'd be cosine, cot. So I'm going to use cosine of 35 degrees, and I'm going to set up my ratio. Adjacent can't be the hypotenuse, so that's 10 over x. So the cosine of 35 equals 10 over x. Now I said I like to solve them just fine like this. However, the book does it. You know, sometimes you seek it instead, the inverse of it, if you don't like to solve this way. But I'm fine using the regular ratios. So I will solve by multiplying by x, thereby giving me x times the cosine of 35 degrees equals 10, because the x's will cross out. And now, to finish isolating x, the only thing I need to get rid of on both sides is the cosine of 35 degrees, leaving me with x equals 10 over cosine of 35 degrees. Go back to my calculator, carefully type that in, 10 divided by cosine, parentheses, of 35 degrees, and I get 12.207, so around the 12.21. And that should be the length of side x. And again, hypotenuse has to be the biggest side, so 12.21 is bigger than 10, so that makes it a reasonable answer. And that's how you find missing side lengths. You have to be given an angle, you have to set the correct trig ratio of that angle equal to the proportion for the sides. Now, how do we work that in reverse? Let's move over here to measure of angle x and y. So here they want me to find the measure of angle x and y in that diagram. And they're going to have to give me some side lengths in order for me to be able to use that. Looks like I forgot to write them down. Let me write some in. Let's go 44 and 18. Okay, and I'm going to find the measure of angle x and the measure of angle y. Now, there's actually multiple ways to do it. It doesn't have to be one way, but I'm going to try to find x first. And from x, the info I have is opposite and hypotenuse. So opposite and hypotenuse is sine, so that's the inverse I have to use. So it's very specific as to what you have. We have opposite over hypotenuse, so we should use sine inverse. The sine inverse for 18 over 44 will give me the measure of angle x. The sine inverse of that. Again, it just kind of works in reverse from the other one. So I have to do the sine inverse function, second sine, 18 divided by 44. And I get 24.147. I'm going to round that to 24.15. And I have the measure of angle x, 24.15 degrees. Now to find the measure of angle y, what I could do is now do the triangle sum and go 180 minus that must be the missing angle. So it's not really required, but while we're here, why don't we see how we could find the measure of angle y using a trig ratio. Well, for that one, I have adjacent over hypotenuse. I have adjacent over hypotenuse. That's a cosine. So I can do the cosine inverse of adjacent 18 over hypotenuse 44, and that would give me the measure of angle y. Let's try that. Second inverse, adjacent 18 over hypotenuse 44, and I get 65.85. 65.85. And if we check, add those together, that's 89, and another one is 90. They do indeed hold together and get the sum. However, remember, I don't have to do both. One or the other could get me all the measures. Just wanted you to see that you could do sine inverse or cosine inverse depending on what angle you choose to use as your reference angle. Okay, let's wrap this up. Word problem-wise, there's a lot of applications of trig. I don't have time to do every single one that they could throw at you, so make sure you're looking at the book and doing the problems in the book as well, because the book has some great applications of this. We talked about measuring the height of a building using our trig ratios. Let's talk about ramps, and there are rules here with how steep a ramp could be. If a ramp's too steep to give someone in a wheelchair access to a building, if it's too steep, they're going to roll backwards. It's not going to be very, very nice for them. So they have rules on what slope it could be. Slope, again, in case you don't know or have forgotten, is rise over run. So there's a couple ways I could go about this problem. They could say that you need a certain slope, in which case I need rise over run, which would be rise over run. Okay, I can find that via Pythagorean theorem because these ramps automatically make right triangles. So you could check the slope by finding rise, finding run, plugging in the ratio, and seeing if it works. Okay, but for my particular example, I need the angle of elevation, the angle from here as it rises up, to be no greater than 5 degrees. If it's greater than 5 degrees, it's too steep. They won't approve it. So they came along, they measured that ramp up, and then measured the vertical distance that that ramp inclined. Let's see if this ramp is acceptable. That means I need to find this angle here. Okay, so that's a problem similar to example 3. I'm trying to find an angle, I do inverses. What do I have to work with? I have opposite and hypotenuse. So I have to make sure I choose the correct trig ratio. Opposite over hypotenuse is so, that's sine. So the sine inverse can tell me the measure of that angle. The sine inverse of that would be opposite, 3.5, over hypotenuse, 45, and that will let me know that missing angle. Back to my calculator to check. Second sine, 3.5, divided by 45, and that's 4.46. So that angle, missing angle measure, is 4.46 degrees. Now, 4.46 degrees is less than 5 degrees. So this ramp does work. Ramp is good to go, however you want to word this. This ramp is good, it's less than 5 degrees. It asks me to explain. Okay, that's where your writing skills come in on these tests. You should put in complete sentences. The ramp is acceptable because it has a steepness of 4.46 degrees, angle of elevation, that's less than 5, that's less than the maximum, it's good to go. How could you show that you know it's 4.46? With the math that we showed here. The sine inverse of 3.5 over 45 gives us the angle, and the angle is 4.46. Okay, hopefully this helps you. The nice thing about this test is there can be a lot of choice with what ratio you use depending on what angle you choose as your reference angle. So you do get a nice degree of freedom here, but at the same time there's going to be situations where you're forced to use whatever ratio, you know, is required for that problem. So you got to learn them all. So remember, so kat toa, and you will be victorious. Thank you.